Hello everyone, this is our IoT project, Smart Home Automation using IoT. This is an internship under Amertex Technologies. Let's go into it. So this is our team. Myself, Srihar Karthik, my friends Rupnath and Mohammad Soeb. So the contents of this PPT. The topics we have learned: what is IoT, IoT architecture, what is embedded systems, project requirements and implementation of this project, and conclusion. The topics we have learned: basics of C programming like keywords, basic data types like integer, char, float, double integer, etc., and operators. So and other topics like conditional contract and looping, concepts and arrays, pointer functions, built-in and user-defined functions, storage classes, preprocessor directives, and header files. So, OOP concepts in C++ we have learned, and introduction to IoT, definitions of IoT, IoT architectures, introduction to embedded systems, definition type of embedded systems, components of embedded systems, peripheral LEDs like peripheral LED like Arduino Uno, CLCD, 14-pin description of CLCD, and ADC, use of ADC in Arduino. We have seen these concepts. So, what is IoT? IoT is a network of devices like sensors, appliances, vehicles, or machines that communicate with each other and with cloud systems over the internet. Examples like smart home, lights, fans, or ACs controlled by our phone. Wearables, smart watches that track your heart rate and steps. Smart cities. In smart cities, like we can control traffic lights, street lights, and adjust the timing of them based on traffic flow. We do this in remote location through a remote location. So industrial IoT, machines in factories sending performance data to monitor efficiency or predict failures. Healthcare, sensors that track patient vitals and send data to doctors. How it works? How IoT works? So devices or sensors. The sensors collect data like temperature, motion, humidity, etc. Connectivity. We send data via Wi-Fi, Bluetooth, or LTE versions like 4G, 5G, or LoRa. The cloud server stores and processes the data. Like Blink, it's a cloud server. So applications display or use the data to make decisions like turning off when no one is in the room. So it is a user interface. The pros and cons of IoT. The key benefits: automation and remote control and better efficiency and resource management, real-time monitoring and analytics, predictive maintenance, especially in industries. Challenges: security and privacy of data, network reliability, interoperability, and scalability. Architecture of IoT. So this is an main basic architecture of IoT, where it consists of sensors which collect data from real time. So the data is transferred or transformed using LoRa to MQTT. So there is a local backend like Python or Node.js we use. So and we send that MQTT to application like user interface. So where we can control everything. So my friend Suhaib will continue.
Hello, my name is Mohammed Suhaib. I am going to explain what is embedded system. And embedded systems are specialized computer systems designed to perform specific tasks within a larger device. They consist of hardware and software that work together to control functions. For example, washing machines, cars, and medical devices. IoT, on the other hand, connects embedded system to the internet to collect and exchange data. In short, embedded systems work locally and independently. IoT systems use embedded devices that are network connected. Every IoT device is an embedded system, but not all embedded systems are IoT device. Example, a digital watch, which is an embedded system. A smartwatch sending health data online is an IoT device. Here we can see the detailed embedded architecture. The analog to digital converter RTOS, actuator, ASICs, hardware, and sensors were connected to microcontroller, which is the brain. Main objective of our project is automatic garden lighting control. The brightness of garden lights adjusts automatically based on sunlight intensity. As sunlight decreases, the light becomes brighter. Smart temperature controller system. The heater and cooler can be turned on and off remotely. The heater switches off automatically if the indoor temperature exceeds 35 degrees Celsius. Automated water tank management. The inlet and outlet valves can be controlled remotely. The inlet valve turns off automatically when the tank is full and turns on automatically when the water level drops below 2000 liters. Tools required. The hardware tools we have used are Arduino Uno, PCF8574, ATH, W5500, temperature sensor, LDR sensor, LCD, HT44780, and LEDs. The software tools we have used are Arduino IDE, PixSimLab used for simulations, Null Modem emulator, and Blink IoT app, which is a cloud server. What the, what the tool does? An Arduino Uno, a microcontroller board based on the Atmega 328P, used to control and interface sensors and devices. PCF 8574, an I2C based input-output expander that increases the number of input and output pins available to the Arduino. ETH W5500, a hardwired TCP/IP Ethernet controller that enables the Arduino to connect to the internet for IoT applications. Temperature sensor measures ambient temperature and converts it into an analog voltage output readable by the Arduino. LDR sensor, a light dependent resistor that detects light intensity and changes resistance accordingly. LCD HT44780, a character display module used to show data such as temperature, light levels, and system status. Thank you. From here onwards, my friend Rupnath will carry on.
Hi all, my name is Rupnath and I am going to say about methodology of the project, system setup and hardware integration. And we have used controller as Arduino Uno and peripherals are LDR, LM35, temperature sensor, LDS, water level sensors. And connectivity is ETHW 5500 Ethernet module for IoT communication. And support devices are PCF 8574 as input output expander and LCD HD 44780 as status display and sensor data and control logic. LDR adjusts the garden light brightness based on the sunlight intensity, and LM35 controls heater auto off above 35 degrees Celsius, and water sensor automates tank inlet outlet valve if on less than 2000 liters off when it full. And IoT and simulations. Blink app, remote monitoring and control using button and gauge weights. Simulation tools or PICS, MLab and Null Modern emulator for virtual testings. LCD display shows temperature, water level and device status. And we can receive notifications, alerts for temperature if tank level reaches its threshold. And we can see when loading the HCX file. And if LDR is high, you can see in the display LED is on, and if LDR is low, LED is off. And from this here you can see color on and color off in the display bar. And in this slide you can see that heater is on, the blue color is filled and heater is off, you can see from the display. And inlet valve, and you can see from this diagram inlet valve is open, and from right side you can see in valve is off, and see outlet valve is on and outlet valve is off in the status bar. And from this here you can see heater temperature notifications, and if heater automatically turns off if temperature rises above 35 degrees. And water level of the tank notification can be received from here. And if the water level ID full, the inlet valve will off automatically. And here you can see water volume level clearly. And by the way, conclusion is using the Blink IoT application and PICS MLab simulator, a home automated system was simulated where LEDs, the temperature setup, and the serial tank represent lights, heater, cooler, and water tank in real time. The CLCD functions as a dashboard, displaying system events, while button weights in the Blink app control the heater, cooler, and inlet outlet valves. Gauge weights are used to show real-time temperature and water volume readings. And this is a topic about our topic how we do it. Thank you.